students, in last lecture already we see that first chapter of chemistry solid state. Complete the first chapter of chemistry solid state. In this lecture we start the second chapter of chemistry is solutions. Solutions means the mixture of two or more content, that is solutions are homogeneous mixture. Homogeneous mixture means the solute and solvent are completely dissolved to form only one layer. Means homogeneous mixture. Solution has two types. First is homogeneous mixture and second is heterogeneous mixture. Homogeneous mixture means solute is dissolved in solvent completely to form only one layer, called as homogeneous mixture or homogeneous solutions. Then second is heterogeneous. Heterogeneous means there is no dissolution of solute into the solvent properly. That is, it gives different two layers of the solution, called as heterogeneous mixture or heterogeneous solution. Then solutions are made by the mixture of solute and solvent, that is dissolution of solute to the solvent in proper way. That is, the amount of solute when added to the solvent, it gives first dissolve completely, that is, it gives saturated solution. But after addition of again and again addition of solute to the solvent, the equilibrium is formed between the solute and solvent. Here the solute does not dissolve properly due to the amount of solute is excess in this process, so called as the equilibrium between crystallization and dissolution. When solute is added to the solvent to form a solution, that is equilibrium is established between dissolution and crystallization. Means dissolution rate of solute is equal to the dissolution equals to the crystallization. Crystallization means the amount of dissolved solute is equal to the amount of undissolved solute, that is dissolution and crystallization. Then next point is the solution has 9 types, that is types of solution, 9 types. Here the chart of types of solution depends on the nature of solute and nature of solvent. In first column, the nature of solute, solid, first 3 types, and solvent, solid, liquid and gases. That is, solid is dissolved in the solvent, solid is dissolved in liquid, solid is dissolved in gases. Means 3 types. Again the solute is liquid dissolved in solid, liquid dissolved in liquid dissolved in gases. Again next 3 types, gases as a solute, means gases dissolved in solid, gases dissolved in liquid, gases dissolved in gases. Means there are 9 types of solution, depends on the nature of solute and solvent. Here the examples of these 9 types. First, solid means metal alloy. Then second, solid liquid means seawater. Seawater contains liquid and in which solid particles are solid. Again, solid in gases means I2 in air. solid in gases, iodine is the solid dissolved in the air. Again, solute is liquid and solvent is solid. Means mercury as a liquid in silver. Silver is solid. Again, liquid in liquid means ethanol in water. Ethanol dissolved in the water. Again, liquid in gases, chloroform as a liquid dissolved in gases means in nitrogen. Then next three types. Here the solutes in the form of gases. Gases in solid means gases like H2 in palladium, palladium metal as a solid. Gases in liquid, that is O2 in H2O, and last is gases in gases means atmospheric air. Air contains different types of gases. The mixture of these gases means example air. These are the 9 types of the solution. Then next type depends on this. Next point depend on the types of solution. Their dissolution, crystallization means capacity of solution to dissolve solute. Many or mostly solvent having capacity to dissolve the amount of substance as according to their property means different solvent has different dissolution rate of the solute. Therefore, the capacity of solvent to dissolve the solute in which some solids or some solute dissolve in suitable solvent easily. Like first is saturated solution. Saturated by dissolution of solute in solvent gives different types of solution. That is first is saturated solution. Saturated solution contains the maximum amount of solute dissolved. That is when solute is added to the solvent, then in the solution first when solute is added to the solvent, the maximum amount of solute is dissolved. Means the solution here to form a solution, this solution contains less number of solute particle as compared to solvent. Means maximum amount of solute is dissolved. When NaCl is added to the solvent like water, then here to form a saturated solution. Saturated solution means the amount of dissolved NaCl is greater maximum as compared to the solution, solvent. Means saturated solution. The maximum amount of solute dissolved. The NaCl is maximum dissolved in this solution, therefore called as saturated solution. Again, second type of solution is supersaturated solution. Supersaturated solution means greater amount of solute than equilibrium amount of solute. Means in equilibrium solution, that is when solute is dissolved with solvent, the equilibrium is established between two processes. That is when addition of NaCl, the rate of dissolution of NaCl is equal to the rate of crystallization of NaCl. When the amount of NaCl is excess, then the rate of dissolution of NaCl is decreases. That is solute plus solvent. Firstly, the dissolution takes place here, dissolution, then to form a solution, and again the rate of crystallization. When the excess of solute is added to the solvent, the solute cannot be dissolved easily. This process is called as crystallization. Firstly, when 50 gram of NaCl is added to the solvent, the 50 gram of NaCl get easily soluble. That is dissolution. Then again 200 gram of NaCl is added to same solution. Here the amount of NaCl is excess, therefore does not dissolve completely. That is to form crystals in this solution. This process is called as crystallization. And in supersaturated solution, the greater amount of solute than the equilibrium amount of solute. Means in supersaturated solution, excess of solute present in the solution. Means there is no dissolution of supersaturated solution. Means no completely dissolution of solute particles. Solute particles means the saturated solutions are completely dissolved and supersaturated solutions having more number of or excess number of solute particles. These are the capacity of solvent to dissolve the solute. Means solute easily dissolved, and in saturated and in supersaturated the amount of solute is excess. Then next point is solubility. Solubility means the rate of amount of solute dissolved, the rate of dissolution of solute in the amount of solvent, that is per unit volume of saturated solution. The rate of dissolution of solute per amount volume of saturated solution at specific temperature. Solubility means the dissolution rate of solute per unit volume of the saturated solution. The solubility is expressed in terms of, means their unit is mole per liter. Mole per liter means how many moles of solute dissolved per liter, called as solubility. The amount of moles per liter of solvent called as solubility. Then next point is of solubility, that is factors affecting solubility. There are many factors which are affect to the solubility, rate of solubility, from which first is nature of solute and solvent. The solubility, the factors affecting solubility, first is nature of solute and solvent. Means when formation of solution, the solubility is depend on which solute dissolved in which solvent. Means ability of solvent to dissolve the solute. Here first point, first factor, nature of solute and nature of solvent. That is, in this point, polar solute dissolved easily to the polar solvent means polar solvent having greater tendency to dissolve the polar solute. But polar solute is dissolved weakly in the non-polar solvent. Means polar dissolved in polar. For example NaCl in H2O. When NaCl is dissolved in water, this is solute and H2O is solvent. Both are polar. Polar means delta positive and delta negative ion. Means Na plus and Cl minus. Also in H2O, H plus and OH minus. Therefore, the polar solvent having greater tendency to dissolve the polar solute like NaCl. Again, next point is non-polar solute dissolving non-polar solvent easily. That is, the non-polar solvent having greater tendency to dissolve the non-polar solute. Example, cholesterol, non-polar solvent having tendency to dissolve the non-polar solute. Example, cholesterol dissolved both are non-polars. Means cholesterol when added to the benzene, the cholesterol easily get dissolved. Then next point of factors affecting solubility. First type is nature of solute and solvent. Then second type of factors affecting solubility is temperature. The temperature also depends for the dissolution or for the solubility of solute in the solvent. Means second is temperature. Nature of the temperature or effect of temperature on the solubility. Some solute dissolve easily in the solvent when increases the temperature. But opposite that, other solutions when temperature increases, then dissolution rate of solute in the solvent is decreases. First here we see that when temperature is increases, then the rate of solubility increases. For example, mostly all cases having this property like increases the rate of solubility with increases the temperature, and exceptional some solutions are the solubility of these solutions are decreases with increasing temperature. The example of the increases rate of solubility with increasing temperature is KCl is dissolved in water. When KCl, potassium chloride, dissolved in water, by giving heating or temperature, KCl get easily dissolved in H2O. And some other examples like CaCl2 means calcium chloride dissolved in water. These are the endothermic and exothermic reaction. First is endothermic reaction. In endothermic reaction, heat is required. Therefore, increase in heat or temperature, the solubility increases. And when KCl is added to the water, the reaction is exothermic. And due to exothermic reaction, here the temperature is not required. Therefore, when temperature is increases, then the dissolution rate of CaCl2 in water is decreases. When temperature increases, then solubility is decreases because the reaction is exothermic. Addition of CaCl2 calcium chloride in water, the reaction is exothermic. Here the addition of KCl in water, this reaction is endothermic. Endothermic means heat is required, heat is absorbed, called as endothermic, means plus delta H. And here exothermic means heat is evolved, means minus delta H. When reaction is carried out, then the temperature is released or heat is released. Therefore, called as exothermic reaction. Then next point, the graph is depend on this point, that is temperature, solubility of solute in solvent with the respective to temperature. Here we see the graph for variation of solubility with respective to temperature. Solubility with increase in temperature for some solutions. First here 0, 50, 100, 150, 200, 250 and temperature 20, 40, 60, 80, 100. First, when solubility temperature is increases, then NaCl, NaBr, here KCl and NaCl solution. Also the solubility more than 100 NaBr. First point from the graph here, conclusion, the solutions like NaCl, KCl and NaBr with change in temperature does not change rapidly. The solubility of these three solutions, that is NaCl, KCl and NaBr, does not change or increases rapidly. The change is slowly, that is when temperature is increases but solubility remains constant. Here solubility is 50, 60, 70, means does not change rapidly. Here also in NaCl solubility is decreases and in NaBr solubility is also constant. Means first conclusion for these three solutions, the solubility is NaCl, NaBr, NaCl and KCl having solubility slightly changes with change in temperature. With change in temperature. Again, next solutions like KNO3 and NaNO2. This is graph for KNO3 and graph NaNO3. For second conclusion from the graph, two solutions of KNO3 and NaNO3 with changing or with increasing temperature, the curve goes rapidly in upward direction. Therefore, the KNO3 and NaNO3 having solubility change rapidly with increase in temperature. Then last is Na2SO4. In last case, the solubility decreases with increase in temperature. Third is for Na2SO4, solubility is decreases with increase in temperature. That is, the solubility with respect to temperature depends on the nature of solution. Some solutions having solubility increases with increasing temperature and some having slightly change or constant, and some solutions like Na2SO4 having solubility decreases with increasing temperature. This is the second factor affecting solubility, that is temperature. Temperature affect the solubility. Then third point is effect of pressure on the solubility. Third is effect of pressure on solubility. Effect of pressure on solubility. The pressure does not affect on the solutions like solids and liquids. Solids and liquid, due to solids and liquids are incompressible. When giving the pressure does not compress the solid and liquid solutions. Therefore, the pressure does not affect to the solid solutions and liquid solutions. They only affect to the gaseous solutions, means gaseous mixture. Then here, when the gaseous solution compress or giving to the pressure, the gas is compressed, that is solubility increases. Here pressure is increases to the gaseous solution, the rate of solubility is also increases. which here we study the Henry's law. Henry's law is depend on the solubility and pressure. Henry's law is depend for board exam for 2 marks. It is very important law for HSC board exam, in which Henry's law important for 2 marks. The statement is very easy, depends on the solubility and pressure. Solubility of gases solutions is directly proportional to the pressure. That is statement when solubility of gas in liquid is directly proportional to the pressure of gas. S for solubility, P for pressure. Then S is equal to KH into P. When cancel the directly proportional sign, we get equal and constant. Constant means proportionality constant KH. KH proportionality constant for Henry's law. Therefore, S is equal to KH into P. Then proportionality constant KH is equal to S upon P. This is the value for proportionality constant for Henry's law. And the unit of proportionality constant is S, having S means solubility, mole per liter, and pressure having unit is bar. Therefore, the proportionality constant's unit is mole per liter per bar. That is mole per liter per bar. Then here the numerical is on Henry's law. We start the numerical for Henry's law. This problem is very easy to solve due to the formula S is equal to KH upon KH into P. Very easy. The numerical, when the solubility of N2 gas in water, solubility of N2 gas in water at 25 degrees Celsius temperature, and 1 bar is 6.85 into 10 raised to minus 4 mole per liter. Given data, then first calculate Henry's law constant. Henry law constant. Also, second calculation for molarity of N2 gas dissolved in the water under atmospheric condition when partial pressure of N2 in atmosphere is 0.75 bar. In numerical, solubility of N2 at temperature 25 degree is 1 bar, means 1 bar. Bar is the pressure, therefore P is equal to 1 bar. And solubility is equal to solubility having unit mole per liter, means 6.85 into 10 raised to minus 4 is the solubility. Yes. From these data, we find molarity of N2 gas at 0.75 bar temperature. Molarity means moles per liter, means yes, means solubility. Solubility question mark for P 0.75 bar. Here solubility for 1 bar we find out here. Calculate the solubility for pressure 0.75 bar. For this, first we calculate to S upon P. S is given, that is 6.85 into 10 raised to minus 4 mole per liter upon P. Pressure is 1 bar. Therefore, KH is equal to 6.85 into 10 raised to minus 4. Unit is mole per liter per bar. From this KH, we can calculate the value of solubility or molarity of N2. Means second calculation, again the formula of solubility S is equal to KH into P. S is equal to KH 6.85 into 10 raised to minus 4 mole per liter per bar into pressure. Pressure is given 0.75 bar. 0.75 bar. Unit bar get cancelled. Remaining unit is mole per liter. 10 raised to minus 4 as it is the multiplication of 6.85 into 0.75. We get the answer is 5.38. Means solubility or molarity. Molarity means how many moles per liter. Means solubility. Means molarity also called as solubility. We get the answer of solubility. Then next point is of vapor pressure of solution of liquids in liquid. Vapor pressure of solutions. Solutions are made by liquid in liquid. Vapor pressure of solutions of liquid in liquid. That is when liquid mix together and their vapor pressure. Liquid in liquid solutions with respect to vapor pressure. In this point, when two solutions of liquid, binary solutions A1 and A2 are mixed together, means A1 and A2 are the volatile liquids. They are taken in the closed container and giving to this pressure. Then both mixture A1 and A2 are mixed together and they are volatile. Therefore they get vaporized. Means the vapors are starts from this mixture. Volatile mixtures. Means then the partial pressure of this component are the pressures giving to the solutions or mixture depends on the mole fractions. Mole fractions of these two solutions A1 and A2 means X1 and X2. Mole fractions means moles. How many moles of solute means X1 and X2. Then according to this relationship between the mole fractions and solubility, we learn that point, we start the point Raoult's law. The Raoult's law is depend on the mole fraction and solubility of the liquid in liquid solutions. Raoult's law is very important for board example for 2 marks. IMP point for 2 marks. Raoult's law statement: when partial pressure of two solutions P1 and P2, that is A1 solution and A2 solution having partial pressure P1 and P2, when dissolved in or mixed together, then their partial vapor pressure of volatile components is equal to the vapor pressure of pure component multiplied by The mole fraction means P1 is equal to X1 P1 naught and P2 is equal to X2 P2 naught. The statement from this formula, again I repeat, the partial pressure P1, P2. The partial pressure of the substance is the mole fraction of solute. X1 is the mole fraction of solute. Mole fraction of solute multiplied to the vapor pressure of the pure solvent. P1 naught is the vapor pressure of pure solvent. Then partial vapor pressure of any volatile compound is equal to the mole fraction of this compound or this solution is multiplied by vapor pressure of pure solvent or substance. Vapor pressure of pure substance. P1 is the partial pressure, X1 is the mole fraction and P1 naught is the vapor pressure for pure solvent. From this equation we get the Raoult's law. Again I repeat the Raoult's law. The partial vapor pressure of any component or any volatile component is equal to the vapor pressure of pure component multiplied by the mole fraction of the solute. Mole fraction of their solute. For first volatile solution P1 and for second volatile solution the partial pressure is P2. Again total these two solutions are mixed together, A1 plus A2. Therefore the total pressure PT is equal to P1 plus P2. PT is equal to, adding the value of P1, X1 P1 naught plus P2 X2 P2 naught. But here binary mixture means mole fraction of both mixtures having summation 1. But here we get the value of X1. X1 is equal to 1 minus X2. X1 is equal to 1 minus X2. Put this value in equation. PT is equal to 1 minus X2 P1 naught plus X2 P2 naught. Here multiplication P1 minus P1 X2 P1 naught plus X2 P2 naught. The simplification of this equation, here P1 naught minus X2 and X2 is common. Therefore next step is PT is equal to P1 naught plus P2 minus P1 and X2 is common. X2 P1 naught as it is, from these two X2 is common outside the bracket, therefore remaining P2 minus P1 and into X2. This is the law of Raoult's law equation for binary mixture. This question is asked in very times in board